Hello everyone, welcome back to our channel Codes Standards Academy. Today we are going to learn about the different types of steels and its respective ASTM standards. Let's get into the video. Firstly, steel is one of the engineering materials used in designing and fabricating products in various sectors like heavy machineries, uh, food processing, oil and gas, petrochemical, and so on. Steel is an alloy of iron, carbon, with some other alloying elements such as chromium, nickel, molybdenum, manganese, silicon, and so on. The steel contains a carbon content up to 2.14%. The American Iron and Steel Institute or AISI classifies steel by an acronym called CAST. C for carbon steel, A for alloy steel, S for stainless steel, T for tool steel. Now let's learn about these four types of steel in detail. Coming back to the carbon steel. Carbon steel is a common type of steel that is an alloy of iron and carbon. Carbon steel has a high tensile strength and hardness, but its corrosion resistance is poor. Carbon steel contains a carbon content up to 1.5%, which gives us three different types of carbon steels as follows: low carbon steel, medium carbon steel, and high carbon steel. This is the overview of types of carbon steel. Under the low carbon steel, it is used for industrial products and for machine components that do not require high strength. These low carbon steels tends to more corrosion when they exposed to atmosphere. And some of the products we can make using low carbon steels are bolts, nuts, sheet metal, plates, seamless pipes and tubes. And medium carbon steel. Medium carbon steels will have a better strength and toughness than a low carbon steel. Some of the products we can make using medium carbon steels are automotive components such as gears, axles, connecting rods, and we have railroad equipments. And finally, the high carbon steel. These are difficult to weld, cut, and bend. Once heat treated, this carbon steel becomes extremely hard and brittle. The applications of high carbon steel include cutting tools, drill bits, cutleries, etc. Coming back to our acronym CAST, the second letter A stands for alloy steel, which are made by combining carbon steel with one or more alloying elements. Adding different combinations and proportions of elements gives the steel different characteristics. As you see in the table, by adding the following elements, we can get these effects in our material. The third letter in our acronym CAST, S, stands for stainless steel. These are called stainless steel because of the presence of chromium, which reacts with the surrounding oxygen. It forms the protective chromium oxide layer which protects the stainless steel from corrosion. And this process is called passivation. For a stainless steel, the minimum chromium content requirement is 10.5%. In stainless steel, the carbon content is limited to some trace amounts, because if we increase carbon content in stainless steel, the carbon reacts with the chromium and it will form a chromium carbide, which is extremely hard. The stainless steels are broadly classified into five types, which are austenitic stainless steel, ferritic stainless steel, duplex stainless steel, martensitic stainless steel, and finally precipitation hardening stainless steel. Now let's learn each type in detail. Austenitic stainless steel. These steels generally composed of chromium, nickel, manganese and molybdenum. They are non-magnetic and have excellent corrosion resistance, but they are susceptible to stress corrosion cracking. They are the most ductile of all stainless steels and can be formed easily. And these are the reference standards ASTM 240 and ASTM 182, and all the reference standard discussed in this video which are given in the description. You can visit those links and you can download all the reference standards, and after completing this video you can refer all the standards. And these are all the some of the example grades for austenitic stainless steel: SS316L, SS304 and SS321. Ferritic stainless steel. These steels have a high chromium content up to 27%. They are magnetic and have a good corrosion resistance, but the ductility is less when compared to austenitic stainless steel. Ferritic stainless steels are hardened by cold working and are not heat treatable. Examples for a ferritic stainless steel: SS430 and SS429. Duplex stainless steel or DSS. These steels combines the properties of austenitic stainless steel and ferritic stainless steels. They have a good strength and have higher corrosion resistance to both corrosion and stress corrosion cracking than austenitic stainless steel. The example grades for DSS are UNS S31803, S32750, S3208. We have four types of duplex stainless steel: lean duplex, standard duplex, super duplex, and hyper duplex. As you see, the chromium content for hyper duplex steel is more than 27%, which means the hyper duplex stainless steel has the highest corrosion resistance when compared to all these duplex stainless steels. Martensitic stainless steel, which have a chromium content between 12 to 17%. Other alloying elements include carbon up to 1.2% and nickel up to 5%. The lack of nickel content makes it less corrosion resistance when compared to all the stainless steels. Example for Martensitic stainless steels are UNS S41000 and S41026. Coming to the final part of stainless steel, which is a precipitation hardening stainless steel. These steels contain a chromium content, nickel, along with copper, aluminum, titanium, and molybdenum. They have a good corrosion resistance and ductility. They have a high strength even at elevated temperatures. One additional benefit of this type of stainless steel is its tensile strength can be improved by proper heat treatment. ASTM A693 is the reference standard for precipitation hardening stainless steel. Examples for these steels include S17400, S15700. The last letter in our acronym CAST T, which stands for tool steels. Tool steels are specially alloyed steels designed for high strength, toughness, and wear resistance at room temperature and elevated temperatures. Their suitability comes from their distinctive hardness, resistance to abrasion and deformation, and their ability to hold a cutting edge at elevated temperatures. ASTM A681 is a reference standard. Some examples of tool steels are T20810, T20811. These tools here finds extensive applications in all drill bits. If you found this video useful, like this video, share it with your friends, subscribe to our channel Codes and Standards Academy, and if you have any doubt in any terms, type of steel, its terminology or its reference code, kindly write in a comment box so that I will try to resolve your queries. And finally, thank you for watching.